Chapter 5, Brakes and Clutches. We'll see the second part of this chapter, which is the clutches. What is a clutch? A clutch is a machine member used to connect the driving shaft to a driven shaft, as shown here. This is the driving shaft, this is the driven shaft, and this is the clutch plate. This is used to connect the driving shaft and the driven shaft so that the driven shaft may be started or stopped at will without stopping the driving shaft. A clutch provides an interruptible connection between two rotating shafts. It's a connection between driving and driven shaft. And the popular application of this clutch we know is in automotive vehicles, where it is used to connect the engine and the gearbox. Here the clutch enables to crank and start the engine, disengaging the transmission. So transmission part we are disengaging it and we are able to start the engine, and when we need the power we connect it to the transmission part by means of this clutch plate. Now in order to change the gears also, we have seen that we used to apply the clutches. So what is actually happening is while we are applying the clutch, it is disengaging the driving shaft from the driven shaft, or in fact it is disengaging the engine from the transmission part, and then we can change the gear. They are quite extensively used in production machinery of all types. Therefore, we can consider this driving shaft and driven shaft as two shafts having inertias I1 and I2, and which are rotating at some angular speeds omega 1 and omega 2. These can be brought to the same speed by engaging. So once we engage the driven shaft and driving shaft by means of this clutch plates, slippage may occur between the two elements which are running at different speeds, and energy is dissipated during actuation, which results in temperature rise. Therefore, to analyze the performance of these devices, we should know the following parameters. Therefore, the parameters of interest can be written as the first parameter will be the torque transmitted by this shaft, because when you are connecting the driven shaft to driving shaft by means of the clutch, you have to transmit the torque from one part to the another part. So how much of torque is getting transmitted to the clutch, that is important. Second one is what is the actuating force which comes into play. And third one is the energy loss. This we have discussed, because when two rotating components rotating with of different moment of inertia, rotating at different speeds, when they come in contact, slippage may occur, and this will result in energy loss, and this energy may be converted into heat, and this gives a temperature rise. So these are the parameters of interest for us in designing the clutch. So we will discuss about the friction clutches. As we know, there are different types of clutches in use. In this chapter, we are interested in discussing about the mechanical type of friction clutch. So in this chapter, we will be dealing with mechanical friction clutch. Or mainly it can be called as a plate or disc clutch. And this is an example of axial clutches. Now we will see in detail about this friction clutch. Sorry. An axial clutch is one in which the mating frictional members move in parallel direction. This is shown here. The mating members, basically the driving shaft which is connected to the driving member which is connected to the driving shaft, and the driven member which is connected to the driven shaft, they will be moving in the axial direction which is parallel to the shaft. Now the friction plate is attached to one of the members, and the actuating spring keeps both of the members in contact, and the power is transmitted from one member to the other member. That is, when we apply the clutch, actually when the clutch is engaged, we are applying the force on the spring. In all the cases, in general case, when the vehicle is moving and when we are not applying clutch, there is a particular spring force which keeps the driving shaft and driven shaft in contact with each other through the friction clutch, and the engine power is getting transmitted to the transmission elements. Now when we want to change a gear, we are pressing on the clutch pedal. By doing that, what we are doing is we are essentially taking the driven shaft away from the driving shaft, or we are disengaging the transmission elements from the engine elements, and we change the gear. So when the power of motion is to be interrupted, the driven disc is moved axially, creating a gap between the members as shown in this figure. And when you need a power transmission, this comes in contact with the friction plate, and it is through the friction plate that the power is transmitted from the driving shaft to the driven shaft. Now how do we analyze this clutch plate? There are basically two types of analysis are there. One is the uniform pressure condition, and one is the uniform wear condition. The torque that can be transmitted by a clutch is a function of its geometry, and the magnitude of actuating force applied also depends on the condition of contact. Therefore, when the force which keeps both in contact is a spring force. So when the spring force is higher, the normal force exerted by the driven shaft on the friction clutch plate will be higher, and because when the normal force is higher, the frictional force will be higher, and more torque can be transmitted. So how is this done? So this is done through the analysis of clutch plates. Is done in two cases. One is called the uniform pressure condition, and another is called the uniform wear condition. So what is uniform pressure condition and what is uniform wear condition? This we'll see now. Okay, before considering the uniform pressure condition, we will try to see a general application. What will be the torque carrying capacity of a clutch? Now we know that the clutch plate is operating by the principle of friction only. So when the force is applied here, there is a normal force acting on the clutch plate, and the normal force creates a frictional force, and the frictional force is creating a torque, is transmitting the torque about its center. Now for this analysis, we consider a small portion of the clutch plate which is at a distance of r from the center, and of a small distance of dr. Then we know the area of this small piece or small element of clutch plates will be given by 2 pi r into dr. This will be the area of the small element of thickness dr. Now if P is the load acting on it, if P is the load acting on the clutch plate, the normal force on this small element dn is given by the pressure into the normal area. Pressure into area will be 2 pi r dr. This will be the normal force acting on the clutch plate. Therefore the frictional force let us F will be given as mu times the normal reaction. The frictional force acting in this small area is given by dF is equal to mu times dn, or I will write it as dF is equal to mu times dn, where dN is the normal force acting on this small area of the element. And here if I want to show the frictional force, I can show it this way. Sorry. At any point on the circle, the frictional force will be acting in a tangent direction, and this frictional force will be creating a torque about the center. Now, if this is the frictional force created on the small area element given by mu times dN, so this I can write it as dF is equal to mu times P into 2 pi r dr. This will be the frictional force. Therefore, the total force, total force acting on this clutch plate can be written as integral from 0 to r, small r to capital R, can be written as integral from small r to capital R of df, that will be mu times P into 2 pi r dr. And what will be the torque created by this force about the center? The torque created will be the force into distance r. This will be given by integral of mu p 2 pi r square dr. It will be from d by 2 to capital D by 2, where small d is the inner diameter of the clutch plate. And capital D will be the outer diameter of the clutch plate. Therefore, we have the force is given by integral of small d by 2 to capital D by 2 of mu P into 2 pi r dr, and the torque carrying capacity of this clutch wheel is given by mu P into 2 pi r square into dr. So now we will apply the conditions of analysis, mainly the uniform pressure condition, a uniform pressure theory, and the uniform wear theory. Now, what is meant by uniform pressure condition? Uniform pressure condition assumes that the pressure is uniformly distributed over the entire surface area of the friction disc. In case of new clutches employing a number of springs, this assumption can be valid. That is, the pressure is uniform across the entire area. Therefore, what will be the total axial force acting on this friction disc? The total force is given by integral from small d by 2 to capital D by 2 into mu p 2 pi r dr. So this will be given as mu p is a constant, it's a uniform pressure, so this pressure we can take it outside. 2 pi is also a constant, so integral of r dr will be r square by 2 with the limits. So this will be r square by 2 with limits d by 2 to capital D by 2. This will be given as mu time pi will be given as mu times 2 pi p into capital R square minus small r square by 2, or in terms of diameter it can be written as pi mu p by 4 into capital D square minus small d square. This is the total frictional force acting. What will be the total normal force acting? Total normal force capital P, which is the force applied, will be equal to pi times P by 4 into capital D square minus small d square. This will be the normal force acting on the, so therefore total normal force acting on the clutch plate capital P will be pi P by 4 into capital D square minus small p square. This is the total force which we are applying on the clutch plate, and this is the pressure applied at the contact surface between the clutch plate and the friction and the driving or driven plate. Now what about the torque acting? The torque carrying capacity T is given as 2 pi P mu r square dr integral from small r to capital R. So this will become pi P mu by 12 into capital D cube minus small d cube. This will be the torque carrying capacity of the shaft. Therefore, the total normal force is given by pi P by 4 into d square minus d square, and the total torque carrying capacity of the clutch plate is given by pi P mu by 12 into d cube minus d cube. So this can also be written as mu times capital P by 3 into d cube minus d cube by d square minus d square. In terms of normal force, this can be written as this way, where capital P is a normal force, the total normal force acting on the clutch plate. So in terms of total normal force acting on the clutch plate, this can be written as total torque carrying capacity can be written as mu P by 3 into d cube minus d cube by d square minus d square. So this is the condition for uniform pressure analysis of a clutch plate. Now the second theory is the uniform wear theory. According to this criteria, it is assumed that the wear is uniformly distributed over the entire surface area of the friction disk. This assumption is used for worn out clutches, basically for worn out clutches we use the uniform wear theory, and for new clutch plates we use the uniform pressure theory, and the axial wear of the friction disk is proportional to the frictional work or the work done by the friction, which again is proportional to the frictional force and the rubbing velocity. So we get a general condition that the wear is directly proportional to P into R. P is the intensity of pressure acting on the disk. This is small p. So intensity of pressure into radius of the clutch surface. So when in uniform theory we assume that P into R is a constant. Therefore, what will be the total normal force in this case? We know that as per the earlier case, we have seen that total normal force capital P is given as 2 pi small p r dr integral from small r to capital R. So here this P into R term can be considered to be a constant term. So that comes outside. So we have 2 pi p r integral of dr from capital R, small r to capital R. This will be nothing but 2 pi p small r into capital R minus small r. And we know that P into R is a constant. So we can assume that P into small r is equal to PA into small d by 2, where PA is the intensity of pressure in the inner side, intensity of pressure on the inner edge, and d by 2 is the inner diameter of the clutch plate. So this we can write it as 2 pi into PA d by 2 into capital D minus small d by 2, or we can write the normal force, the total normal force will be given by pi PA d by 2 into capital D minus small d. This will be the total normal force acting on the clutch plate by uniform wear condition. Now we will see the, so what is the total frictional force? Frictional force will be equal to mu times the normal force, and it will be equal to pi mu PA small d by 2 into capital D minus small. That will be the total frictional force. Now we will see what will be the torque carrying capacity of this disc. Now we know that is equal to 2 pi mu into P into R square dr, integral from small r to capital R. We know that P into R is a constant, that we can take it outside. So we get 2 pi mu PR integral of R dr from small r to capital R, which turns out to be 2 pi mu PR into integral of dr, R dr will be R square by 2. So it will be capital R square minus small r square by 2. And this can be written as 2 pi mu into PA into D by 2 into D square minus D square by 8. If the total torque carrying capacity will be written as pi mu PA into D by 8 into capital D square minus small d square, or this can be written as mu times capital P by 4 into capital D plus small d. So this is the torque carrying capacity for the clutch plate or the friction disc in a uniform wear condition. This is the normal force acting on the disc, and this is the torque carrying capacity of the disc for a uniform wear condition. Now when to use a uniform wear condition and uniform pressure condition? The uniform pressure condition is applicable only when the friction lining is new. When the lining is put into service, wear occurs. Therefore, the major portion of the life of friction lining comes under uniform wear criteria. And in the design of clutches, the uniform wear theory is justified. Therefore, when a clutch plate is new, in that condition, uniform pressure theory would be better to analyze analyze the clutch. And once it is put into use, the uniform wear condition will be better to analyze the clutch plate. So we have seen the total normal force and the torque carrying capacity of clutch based on uniform pressure criteria and uniform wear criteria. In this, I would like to say the parameters. Mu is the coefficient of friction between the plate materials. PA is the intensity of pressure in the inner side on the inner edge of the clutch wheel. Capital D is the outer dia of the clutch plate, and small d is the inner dia of the clutch plate. Capital P is the total normal force acting on the clutch plate, and capital T is the torque carrying capacity of the clutch. So now we will see about single clutch and multiple disc clutch. Till now what we have seen is called a single disc clutch or single plate dry clutch. Now the clutch basically needs three parts. One is the engine flywheel, friction disc called the clutch plate, and the pressure plate. When the engine is running, so we have a engine, then we have the friction plate, pressure plate, and the transmission. So these are the parts of the engine. So from the engine the power goes to friction plate, and from there it goes to the transmission elements. Now in general condition, this pressure plate will always be acting on this friction plate, and the pressure plate always, due to the spring force, the pressure plate keeps the the driving shaft always in contact with the driven shaft through the friction plate. So in general condition, when we are driving the vehicle, when we are not engaging the clutch, or when we are not pressing the clutch pedal, in this case the engine and transmission are connected to the friction plate by the spring force applied by the pressure plate. This is a general condition. Now when we apply the clutch pedal, what happens is the pressure plate moves the friction plate slightly away, which creates a gap between the driving shaft and the driven shaft, and the engine and transmission gets disengaged. So when we are applying the clutch, actually we are disengaging the engine and the transmission elements. That is for application of gears. Now when we apply the clutch pedal, we make the pressure plate to move away from the friction disc, and because of the air gaps created between the flywheel and the friction disc, no power can be transmitted to the clutch. So when we are pressing the clutch pedal, when we are pushing the clutch pedal down, the clutch is actually released, and no power can be transmitted to the clutch. Now in multiple disc clutch, it is called multiple because in multiple disc clutch, more number of surfaces come in contact and help in aid in transmitting the torque from one component to other component. When both side surfaces of the clutch plate are used in transmitting a torque, we say that we add a new term to the torque carrying capacity. That is, when we have torque carrying capacity as mu times Fa into Rm. That mu times the frictional force, mu times the axial force or the normal force. This will be the frictional force, and the frictional force into Rm will be give the torque carrying capacity of the disc. Now this is what we have learned till now for single plate clutch. For multiple plate clutch, what happens is we have a new term, that is capital N into mu times Fa into Rm. Or we can write as capital N into mu times capital P into Rm will be the torque carrying capacity, where capital N is the number of friction disc in contact. In contact, mu is the coefficient of friction, and capital P is the actuating force, and Rm is the equivalent radius of the clutch plate. Friction plate. The capital N can be given as N1 plus N2 minus 1, where N1 is the number of driving disc, and N2 is the number of driven disc. So in that case, the total number of servos in contact, like for example, if we have 2 number of driving discs and 2 numbers of driven discs, the total number of servos in contact will be 2 plus 2 minus 1 will be 3. And if we have only 1 driving disc and 1 driven disc, then total number of servos in contact will be 1 plus 1 minus 1 is nothing but 1. That is what we have seen in single plate clutches. Now Till now we have seen how to analyze the clutch plate, how to find out the total axial force acting on the clutch plate, and how to analyze the torque carrying capacity of the clutch plates for different conditions of uniform pressure and uniform wear. Also we have seen when multiple clutches are there, how to incorporate the effect of the multiple clutches. That is nothing but it is incorporated by means of number of friction discs in contact or number of surfaces in contact, which is given by n1 plus n2 minus 1, where n1 is the number of driving disc, n2 is the number of driven disc, and n is the number of surfaces which are in contact. Now we will try to solve some problems. In a multiple disc clutch, there are 6 discs on the driving shaft and 5 discs on the driven shaft. Then the number of pairs of contacting servos will be. So in multiple disc clutch we have seen the number of pairs of contacting servos will be given as n1 plus n2 minus 1. n1 is the number of disc on the driving shaft, which is 6, plus n2 is the number of disc on the driven shaft, this is 5, minus 1 will be 10. So the total number of pair of contacting servos will be 10. Now we will take another one problem. A clutch has outer and inner diameter of 100 mm and 40 mm respectively. Assuming uniform contact pressure of 2 MPa and coefficient of friction of liner material 0.4, what will be the torque carrying capacity of this clutch? Okay, so it is given the condition is given as uniform pressure condition. So for uniform pressure condition, what is the torque carrying capacity? That is given by pi mu p divided by 12 to capital D cube minus small d cube for uniform pressure condition. So here small p will be equal to, it's given as 2 MPa, 2 into 10 power 6, and what else is given? Capital D is given as 100 mm, that is nothing but 0.1 meters, and small d is 40 mm, that is 0.04 meters, and mu coefficient of friction is 0.4. Therefore substituting this relation we get T is equal to pi into P. P is nothing but 2 into 10 power 6 into mu. Mu is 0.4 divided by 12 into capital D cube, that is 0.1 cube, minus small d cube is 0.04 cube. So what will this be? It will be pi into 2 into 10 power 6 into 0.4 divided by into 0.1 cube minus 0.04 cube divided by 12. So how much it will be? It will be 196 Newton meter. Thus, whenever the problem is given, it's always better to write down what are the parameters given and what is the unknown value to be found out. Then you can write a relation connecting the unknown parameter, here the torque, and the known parameters, which are nothing but these parameters. Then it's only a substitution. Now we will take one more problem. A disc clutch is required to transmit 5 kilowatt power at 2000 rpm. The disc has a friction lining with coefficient of friction of 0.25. The bore radius, that is the inner radius of the lining, is equal to 25 mm. Assuming contact pressure, uniform contact pressure of 1 megapascal, what will be the value of the outer radius? So what all things are given? Now the power transmitted is given as 5 kilowatts, it's 5000 watts, and the RPM is given as 2000 RPM. Then what else is given? The coefficient of friction is 0.25. The bore, the inner radius is given, that is inner radius is small r is equal to 25 mm, or we can write small d is equal to 50 mm, This is equal to 0.05 meters, and the uniform contact pressure small p is equal to 1 megapascal, that is 1 into 10 power 6 pascals. Now we have to find what is the outer radius of the friction lining. So how do we approach the problem? Now the power is given and the speed of rotation is also given. So the relation connecting these two is given by P is equal to 2 pi nt by 60. The P is the power given as 5000 watts is equal to 2 pi. N is the RPM of the machine, that is given as 2000 T by 60. So we know we can get what is the torque to be transmitted by this clutch. So it will be 5000 into 60 divided by 2 pi into 2000. The torque to be transmitted will be 23.87 Newton meter. The torque is given as, for uniform pressure condition, the torque carrying capacity of the clutch is given by pi mu p by 12 into capital D cube minus small d cube, which gives capital D cube minus small d cube will be equal to 12 into 23.87 divided by pi into mu is 0.25 into p is 1 into 10 power 6. This will be equal to 3.647 into 10 power minus 4. Now what will be small d here? Small d is 0.05. Therefore capital D cube will be equal to plus 0.05 cube. This will be 4.897 into 10 power minus 4 meters. Our capital D will be equal to cube root of this, to be 78.82 meters. Therefore the capital R, the radius, outer radius will be given by 2, that is 39.4 mm. So this is mm, sorry. So this way we can find out what will be the outer radius of the shaft. It will become 39.4 mm for this case. Therefore, as I have already told, first write down all the parameters which are given and find a relation between the unknown value which has to be found out and the known parameters. Once you write that relation, then it becomes only substitution problem. So that is about the clutch plates. Now I'll spend some time on so we'll see about the conical clutches, how it will be. Now we'll see for cone clutches. In disc clutches we have seen that the surface in contact is flat. In cone clutches it has got some angle alpha. Alpha is the cone angle, or semi-cone angle of the clutch plate is alpha. Then we have the total normal force acting on the clutch plate as per uniform pressure theory is given as pi by 4p into d square minus d square, where capital D is the outer diameter and small d is the inner diameter. And the torque carrying capacity is given by pi mu p by 12 sin alpha into capital D cube minus small d cube, where alpha is the semi-cone angle of the clutch plate. It can also be given in terms of the total normal force also. This is for uniform pressure conditions. Now we have the similar relation for uniform wear condition. For uniform wear condition, the total normal force capital P is given as pi PAD by 2 into capital D minus small d, where PA is the intensity of pressure in the inner side, and small d is the inner diameter, capital D is the outer diameter of the clutch plate. And the torque carrying capacity T is given as pi mu PA into D by 8 sin alpha into capital D square minus small d square. So you can see that here the additional term of sin alpha comes into picture because of this, because of the angle of the cone, where alpha is the semi-cone angle. Of the clutch plate or the friction plate. So this can be given in terms of the total normal force also as mu times capital P divided by force sin alpha into capital D plus small d. This will be the torque carrying capacity of a clutch plate subject to uniform wear for a conical clutch plate. So with this we come to the end of this chapter on the clutches. So next so that brings to the end of this chapter 5 on brakes and clutch plates, brakes and clutches. Thank you.